Hello everyone, welcome to my channel. Today we are going to derive the shape function for constant strain triangle element. So this is our triangle, node 1, node 2, node 3, and with degrees of freedom u1 v1, u2 v2, and u3 v3. So for deriving the shape function, we use the polynomial which we get from the Pascal's triangle. So if I have to remind you about the Pascal's triangle, it was like this: 1 xi eta xi square xi eta, and sorry, now the xi is gone, xi eta, and then eta square xi cube xi square of eta xi eta square eta cube. And in previous video we did linear bar element, so we took this term, right? But since this is our triangular element, we take the triangular term like this. So for our case, we have the triangular element with 3 nodes. So what we take is this portion of the Pascal's triangle to set our polynomial function. So we take this thing. So 1, xi, and eta are our terms. Okay. So likewise, if we represent displacement u with respect to these polynomials, then we said alpha 1 times 1 plus alpha 2 xi plus alpha 3 times eta, right? And since here we are talking about x and y coordinates, we can substitute this xi and eta with x and y also. So let's just represent this xi and eta in terms of x and y. Simply represent this xi as x and this eta with y. So instead of this, what we get is u equals to alpha 1 plus alpha 2 times x plus alpha 3 times y. And this is our equation number 1. Similarly, this is u is the displacement in x coordinate. For the y coordinate, we do v equals to alpha 4 plus alpha 5 times x plus alpha 6 times y. This is our equation 2 for 2 degrees of freedom. Representing in matrix form, what we get is, let me just this. So in matrix form, in matrix, how we can represent this is u v, simply put here the alpha 1, alpha 2, alpha 3, alpha 4, alpha 5, and alpha 6. And here we have 1, we have x, and we have y. So this is going to be easier for us to represent. So as we know, for each node, there is u1 v1, u2 v2, and u3 v3, which has to satisfy this equation. So if we talk about, let's talk about horizontal displacement u. Okay, so for 3 nodes, we will have u1, we will have u2, we will have u3. If u2 for the vertical displacement v also, it's going to be same. So if you do for u1, u2, and u3 like that, what you get is you just substitute here u1, and for node 1 you put x1, for y you put y1. So you just get this equation like this. You get 1, you get x1, you get y1, 1, x2, y2, 1, x3, y3 times alpha 1, alpha 2, alpha 3. So don't get confused that this thing we just substituted for node 1. Okay, for node 1 what we did is instead of u we put u1 and alpha 1 plus alpha 2 times x1, which is this x1, plus alpha 3 times y1, which is y coordinate for this. Okay, and you get this equation for all the nodes. If you do this for node 1, node 2 and node 3, you get this equation. Okay, our main question is to find this alpha 1, alpha 2 and alpha 3. So let's just focus on that. We just bring this alpha 1, alpha 2 and alpha 3 in the left hand side, and we just give the inverse of this matrix x3 y3 and just invert this matrix, and the rest of the item is u1, u2 and u3, right? So if you open this, what you get is like this, and if you inverse this matrix, then what you get is something like this: 1 upon 2a, I will tell what 2a is, times x2 times y3 minus x3 times y2, then here y2 minus y3, here x3 minus x2, x3 times y1 minus x1 times y3, here y3 minus y1, here x1 minus x3, here x1 y2 minus x2 y1, here y1 minus y2, here x2 minus x1, okay, minus x3 times y2, then here y2 minus y3, here x3 minus x2, x3 times y1 minus x1 times y3, here y3 minus y1, here x1 minus x3, here x1 y2 minus x2 y1, here y1 minus y2, here x2 minus x1. Okay, just we have to transpose this matrix. Okay, and here we have u1, u2, u3. Okay, where 2a, what is 2a? It is just determinant of this matrix which inverse we have to find. So it is just the determinant, which is just 1 x1 y1, 1 x2 y2, 1 x3 y3. Just find the determinant of this matrix, and then you get 2a. Okay, it is just for the representation that we have written this, where a is the, what is a? A is the area. Okay, a is the area. We got this formula, and here 2a, this 2a is nothing but determinant of this matrix that we are talking about, whose inverse we are finding, determinant of this matrix. Okay, and A is the area of triangle. Okay, A is nothing but area of triangle. Okay, so for easiness we represent with 2A instead of writing whole things. And now we are also going to represent this same equation in more shortcut. Way. So alpha 1, alpha 2, alpha 3 equals to 1 upon 2A. Now what we are going to do is we're going to represent this with ABC terms. So for example, instead of writing this every time, I'm just going to write A1, and second term is B1, third term is C1. Similarly, A2, B2, and C2. A3, B3, and C3. And we are going to transpose this, and the rest of the term remains as it is. So now we are almost there. Okay. So finally, what we get is alpha 1, alpha 2, and alpha 3 equals to 1 upon 2A. When we transpose this matrix, we are going to get A1, A2, and A3, B1, B2, and B3, C1, C2, and C3. Now we already transposed that, so we are not going to write it again this way. Okay, so now we got this alpha 1, alpha 2, and alpha 3 in this form. Okay, so now we can represent u in terms of this equation. So if you go a little bit in the previous equation that we derived, for example, if you go to this equation over here, then general formula, okay, general formula for displacement u, what you can write is u equals to 1 x y, and then you can write alpha 1, alpha 2, and alpha 3, right? This is the general formula. Okay, so it is just this equation we are writing in matrix form, but now we got alpha 1, alpha 2, and alpha 3, so we are going to substitute like we did in previous sessions as well. It's the same process. Okay, so we are going to substitute this alpha 1, alpha 2, alpha 3 in this equation, because we are in this equation, in equation number, let's say as equation number A, equation number A. So we are going to substitute in this place. So what we get is u equals to, so this is 1, this is x, and this is y. And instead of this alpha 1, alpha 2, and alpha 3, we are going to substitute this value. Okay, it's not so difficult. So 1 over 2a, and simply a1, a2, a3, b1, b2, b3, c1, c2, c3 times u1, u2, and u3. Okay, hence we get this in the form of u equals to n1 times u1 plus n2 times u2 plus n3 times u3, where u when you multiply these terms with this, you can get in this form. So only the displacement part is this one, and rest of these parts are our shape functions n1, n2, and n3. Okay, so if you multiply all these terms, what you are going to get is u equals to, we're just gonna divide m. We are just going to multiply this matrix, matrix 1, with this matrix. Okay, matrix 2. We are going to multiply these two and give the term under 2a. So what we are getting is a1 b1 times x plus c1 times y divided by 2a. This is our first term. Second term is a2 plus b2x plus c2y over 2a. Similarly, a3 plus b3 x plus c3y over 2a. Okay, so we didn't do anything much here. We just multiply those two matrices. We are just putting u1, u2, and u3 here. So now you get this equation in this form, where this is your shape function n1, this term is your shape function n2, and this is your shape function n3. Okay, it's not so difficult. And so finally, if you have to conclude, hence shape function n1 is going to be a1 plus b1x plus c1y over 2a, and 2 is going to be a2 plus b2x plus c2y over 2a, and n3 is going to be a3 plus b3x plus c3y over 2a. Okay, now a little bit writing over here I would like to do as a conclusion. Here a1, if you compare from the matrix elements, is x2 u3 minus x3 y2. So a2 is x3 y1 minus x1 y3. a3 is x1 y2 minus x2 y1. b1 is y2 minus y3. b2 is y3 minus y1. b3 is y1 minus y2. c1 is x3 minus x2. c2 is x1 minus x3. c3 is x2 minus x1. And formula for calculating the area is this one. Okay, so this is basically it. And you remember that all the process starts with the Pascal's triangle, whichever element we want, and we just represent this way. And if you do the similar thing for B as well, then you can get the similar formula. Okay, this was for our displacement horizontally. For B also, you can do it that way. the shape function won't change. Okay, so for example, now for example, okay, so for vertical displacement v, for v it is similar. So v also you can get n1, n2, and 3, which are basically the same thing that we found here, n1, n2, and 3. But now here the displacement won't be u1, u2, u3. Instead it will be v1, v2, and v3. That's it. Okay, that's it. So I hope you understood this, and see you guys in next video.